Good morning everybody. My name is Pepper. One of High-Tech Power Inc.'s humanoid robots.
And I am Now. Today we are here live from our high-performing innovators Cyber Hub.
Today, we are going to present to you series of webinar from our experts that will be simultaneously playing from our booth in SMX convention for PSIM.
Hello to our visitors and clients from our booths.
We are so happy to see all of you. To our HPI family, fighting. So let's start. First presenter for today is entitled FME Solutions. Please roll VTR.
We're going to focus on one of the solution that we have, which is the mechanical tensioner, or also known as SuperVolt. All right. Before I get to the product, let's have a quick refreshment about how does a bolt work. So on the animation here, you can see on the left, we have spanner, which is trying to turn or trying to torque the nut. And you can also see below that before the nut is tightened, the length is as is. But after it is being tightened, we can see that the length has been elongated. Right? And why so? And we also see a bolt as similar to a spring. Right? When we elongate the spring, then the spring is going to try to come back to its original length, and because of that, it creates a preload in the spring or in the bolt, which will then try to climb apart. That's what you see in the right animation here. So simple principles of the bolt. And I just quickly go through the top formula. Right, there are many top formula around today, which is there are many, but there's not one that is most accurate. They are all quite similar. And based on the Kellerman and Klein top formula, we see that the top is actually a summation of 3 parts. Right? There is a top to actually overcome the head friction between the bolt head and the part, right? Which this formula. And there's also top to overcome friction inside the threads. And then there's also top to effectively stretch the bolt, right, to give us the preload to climb the part. So torque is a summation of these 3 parts. And when we derive this torque formula, we found out that torque is actually a function of a constant, right, multiplied by a bolt diameter to the power of 3. So what does this tell us? When we have torque to the bolt diameter to the power of 3, we actually get an exponential increase of torque when we get a larger bolt size. For instance, you can see in this example, if we have a 1-inch nut, typically that would take us 365 foot-pound, right, to tighten this nut to the nominal level. But when we have a 4-inch nut, right, only 4 times larger. So how much torque do we need? Is it 4 times more? But no. So the torque needed to tighten a 4-inch nut to its nominal preload will be 37,850 foot-pound. That's not 4 times more, but it's more than 100 times more torque. Right? So we now know that as the bolt size go bigger, the torque increases exponentially, which may cause some kind of inconvenience. So on the video here, you can see that this looks like a reactor cover, and these guys, they are really hanging this kind of huge steel bar onto a frame. And there are 4 of them to try to push the weight of it, to exert a force to try to undo the bolt here. So it doesn't look very safe. And I have another one. This one was actually a quite recent one. It was only taken last month. And one of our so this was how we were doing, right, to undo the boat before. So doesn't look like the best way to undo a boat. And here I have one more. This was the case. You can see there's a very large bolt on top of the machine here. So they actually welded a handle, two handles on the side or on the edge of the nut. And then they use multiple chain blocks below here. And there's 5 guys here trying to pull the handle with the chain block. So doesn't look like the most ideal way doing large bolts. So what happens when you have large bolts? Typically bolts of diameter over 2 inches. The first, of course, high energy equipment frequently causes injuries. That is somehow inevitable. As safe as we are, but it's only a matter of time. Then you see accidents. And when we derived the torque formula, we also found out that 90% of this torque is actually wasted to overcome friction, right? Friction under the boat head and also friction in the treads. Right? Approximately just 10% is used to actually elongate the boat. And nowadays, a lot have resorted to hydraulic torque wrenches. That is also a good method, depending on the criticality of the equipment. If you need a high accuracy, then it may not be the best choice as well, because a preload scatter is going to be quite high. And you can get as much as plus minus 30 to 40% of preload error if due to torque because of the hard to control friction variables in the treads and under the boat head. So here, again through the same formula, if we put in all the constant, we see that when we apply torque, 50% of this torque is used to overcome friction under the head, 40% is used to overcome friction inside the treads, and only 10% is used to friction. Well, of course, this scenario is more apparent for larger boat sizes. For smaller boat sizes, yeah, most of the time it's not a big problem, but if boat size with very large diameter, then this may have a very big impact, getting this plus minus 30 to 40% preload error. Right. So what do we do then? How do we actually tighten or loosen large bolts? We have here today, I'm going to introduce the mechanical tensioner or multi-jack bolt tensioner from the Norlock Group. So it's a basic design. First we have the jack bolts, right? These little bolts you see here, they are all called jack bolts. And then we have the cylindrical nut body, which is housing the jack bolts. And below we have a hardened washer, heat treated and hardened. So consists of only 3 parts. And how do they work? Just play a quick video here. So as you can see, they are actually a direct replacement of the existing hex nut. Right? You remove the existing hex nut, you can use your existing bolts, then you turn down the mechanical tensioner. And after turning it down, you've got to apply torque on all of the jack bolts. And this torque will then, in turn, exert a force on the hardened washer to eventually jack the main stud up, right? Just as we are elongating the bolt when we are applying torque. I'll play that one more time. Right, again, install the tensioner. So direct replacement of existing hex nut. We torque the jack bolts. We are then going to exert force on the hardened washer, jacking the main stud up. And this jacking creates an elongation or stretch which is then converted into direct translated into a preload and then converted into clamping force. Do the two parts together. Right. And the advantage of using such method, over here you can see a curve. On the x-axis we have the both sizes in metric, M30, M60, M90, and on the y-axis we see the torque required in Newton meter, right? 70,000 and 140,000. So as the boat size go bigger, again, to the top formula, we see that it increases exponentially. All right, so as the boat size go really, really big, 120, M120, M150, oh, you get a very, very high torque requirement, but with the multi-jack boat tensioner, it's relatively or extremely low in comparison. So low torque requirement, and we can achieve the same huge clamping force. To see that in a better perspective, here we have a table. Let's focus on the 2-inch boat, right? And if you would target a boat load of 779 kilonewton, all right, with the conventional torquing method, you would need to exert about almost 7,000 Newton meter of torque. But if you would replace this with a super boat tensioner, it would only take 77 Newton meter on the torque wrench to get to the same target boat load. So that can be kind of a huge difference, but again, depends on application. Certain application, it can be more convenient to use a torque wrench, but certain application, if it is high, if we need crane lifting, if we need to climb up the monkey ladder or some space constraint, then multi-jack boat tensioner may be more suitable. So there's none that is best of both worlds, but they're all good for their own advantages. All right, so here, what else do we see as the advantages, right? Of course, with the low torque, that translates to safety, right? Only exerting 77 Newton meter, that's going to be almost effortless, right? You can do that with a Nova 100, so very easy to tighten. Right? Only hand tools are required. And with these tensioners, because we are not overcoming any friction, or there are some, but not a lot. And because of that, you get very high reload accuracy. I would say most of the time we get about plus minus 5%, but in the worst case, you can get to plus minus 10%, but yeah, it's within 5 to 10% of reload accuracy. And here you can see there is a common occurrence, right? Especially with stainless steel boats. So you get check garling, seizing in a tap hole. But because when you do tensioning or with this mechanical tensioning, you're actually stretching the boat directly in pure tension. So that doesn't create any torsional stresses at all, which may lead to occurrence like check garling. So another problem solved. And there's also one part of the design of the superboat tensioner, right? So before tightening, we actually see that the tensioner body or its outer diameter, they are kind of even, right? But after tightening the jack bolts, we see that the tension body actually flexes. Right, in this diagram, it's a little bit exaggerated, but we could also measure it with a vernier. Right, we see that the upper body dimension has shrunk, it has flexed inwards, and the lower body dimension has expanded or flexed outwards. Right, so this actually, what does this do? What does this do? Right, so it actually creates additional elasticity in the joint because it acts just like another spring. right? We learned in the first slide that the boat hold two parts together by an act of just like a spring. Then now we have a second spring on the nut body, and not only that, these jack bolts, when they are tightened up to this nominal strength, right, they are actually being compressed, and this compression also adds additional spring effect. Right, they act as just like a spring as well. So you can see the bolted system now has not only the main stud as a spring, but also the tensioner nut body, and also each and every single one of the jack bolts. So there are a lot of springs in the system now. And what does this spring does? Right? It's really, really useful to complement any kind of loss of preload, especially when we have thermal cycling effect. Right? We have solved countless of problems on heat exchanger, where the expansion and contraction of the bolts and flange are at a different rate. They always experience leakages during startup or shutdown. And because of all these added spring effects, they actually complement preload loss and has kept many heat exchanger secure. So to sum it up, of course, it's a much safer way to tighten large bolts due to the fact that the torque requirement is very low, right? And it's also relatively high preload accuracy. Again, most of the time, plus minus 5%. We can verify that also with ultrasonic measurement, right? And zero torsional stress is introduced. When we do torquing, we normally don't only apply torque on the nut, but indirectly apply some torsional stress on the stud as well. So they are, somehow being twisted as well. So with TMJT, zero torsional stress, and much added elasticity compensate preload loss, right? Especially for applications like heat exchanger, where you have thermal cycling effect. So the Superbolt is not something very new. It is also a company founded in 1985. So it's already been about 35 years now, right? And it has been also used in many industries around the world, railways, steel, oil and gas, entertainment, roller coasters, bridges. Right? So I'll just show a couple of examples here on where they are used. Here we can see the Superbolt being used on a methane reactor, right? Which, yeah, we highlighted thermal expansion because this is one of the joint where we have solved problems with thermal expansion. Right, so you can see Superbolt, we are installed in multiple parts, right, on the bottom flange and on the top flange as well. And this example is for ammonia and urea reactor, where we do this quite a lot as well, solve problems with tightening. So in most cases, they were using cranes for this kind of joint, right, to tighten them. So now we only need to use a simple torque wrench. This is one of the more recent case as well. I think it was only about 2 or 3 months back. 3 or 4 months back. This is a case for gas turbine in the power plant. So yeah, the 4-way joint here, which is not accessible to be tightened with torque wrench or with hydraulic tensioner. Right, so the customer has resorted to Superbolt solution, where you see is very close to the wall of the casing, but that will not be a problem with the Superbolt because we only need some space clearance for the torque wrench, or use a long socket, and we have a lot of clearance to tighten the jack bolts in the turbine casing. This is one reference from Japan. So they are now using the Superbolt also as a PM part on boiler feed pump. So another good application. Use Superbolt. And we do a lot of retrofit as well for boiler feed pump because customer feedback that we're always using OEM boat tensioner and pump often breaks down. So at least today we do not need to rely on hydraulic pump anymore, just relying on the top range. And another reference from this is for heat exchanger. Yeah, one of our best application that we sell to. Because again, heat exchanger with the thermal expansion and contraction always causes a lot of time causes problems during startup, operation startup, and shutdown. And with these, most of the time solves the problem. Yeah, steel plants, of course, where we have many large boats, right? You can see here these are very large in size, but of course can be tightened just with a torque wrench, slightly larger torque wrench, right? Probably 800 Newton meter torque wrench, but yeah, no matter what the boat size is, all you need is a torque wrench to tighten the boat. So this is another case from Japan. Compressor foundation, popular application as well. This is for solar turbine offshore. And they use it to tighten the foundation of the compressor. I think this is the last one I got. One more before we move on. This for wind tower application is split into 3 different parts here. On the first picture, you see it is being used to tighten the foundation of the bearing housing. And the bottom picture, this is actually for the yaw bearing, right? The slewing ring, right, of the nacelle. Right? Those bolts can be replaced with Superbolt tensioners, easy to tighten. And the 2 pictures on the right is actually for the coupling to the gearbox in the nacelle. Right? So these are a little bit more different. It's actually an Superbolt expansion bolt, so they uses the multi-jack bolt tensioner on top, but inside is actually an expansion coupling bolt. But we can leave that for another session in the future. So you can see typically where can we use Superbolt? Almost everywhere, as long as we have a big boat size and we have difficulty tightening it or reaching it in tight space constraint. You can use it with the standard or the existing stud, right? Don't need to change if you do not want to. Like the threads, they are customizable. We can make it into any standard thread dimension or custom thread dimension. Like use it for through hole. Here we have flex nut below. Get to that later. All right, so tensioner and a nut, the other end. And if we have a tap hole and we do not want it to be 2 parts, we can also do it in a bolt style like this. So it's 1 part altogether, right? And not as a nut, but as a bolt. So you only need to care for 1 part. And, even for counter bores, we also have low profile tensioning, right? Which doesn't have its jack bolt sticking out, usually for rotary or high speed equipment. Just to go through a little bit about standard range, these are the standard nut range. We've got medium strength, high strength, bolt style as well, medium temperature. These are really our most common Superbolts. But again, we also have low profiles one. It doesn't have jack bolt sticking out. A few models here, depending on the application needs. And also some special ones, right? Sometimes for high-speed coupling or for cross-head jam nut or something. So there are some special Superbolt as well.
There you go. Thank you to our first presenter. Before we go to our second presenter today, to our friends in SMX Convention, to our friends here in the Cyber Hub who are watching, please scan this copy of QR code for you to have your copy of certification. Thank you.